In this lesson, we're going to be looking at slopes. So first of all, let's actually talk about vertical slopes, get that out of the way. You may remember from Algebra 1 that we talk about slope as being rise over run, so that's how far you go to the left or right on the bottom, and how far you go up or down on the top. So if you have a vertical line, and we're talking about, say, between 2 points on that vertical line, how far you go up or down, well, you could measure that. That's just the vertical distance. But then if we talk about how far you go left or right between these 2 points, well, one's on top of the other. So you don't go to the left or right at all. So the movement sideways is zero. So that means in your fraction, say these are, I don't know, three numbers apart, you'd get 3 on the top of the fraction. But the distance left to right is zero, so you'd be dividing by zero. Well, dividing by zero breaks math. You can't divide by zero. That's not possible to do. And so we have some caveats when we start talking about slopes of vertical lines. We call it undefined. So since we don't have any way of actually dividing by zero, it's not possible to do. We have to say that this is not a defined operation. We can't divide by zero, so we say that that is an undefined slope. And so anytime we talk about slope, we're often saying, oh, except for vertical lines, or in this other case, we have this other weird thing for vertical lines. So that's why we have these caveats here. So in the first part here, it says the slope of a non-vertical line. Again, we just have to exclude vertical lines from things and talk about them separately, because when we talk about vertical lines, we're dividing by zero. So we kind of have to exclude that from some things that we talk about. In any case, the slope of pretty much any line is just going to be the ratio, so that's a fraction, comparison of two numbers, of the vertical change, referred to as the rise, to the horizontal change, referred to as the run. So it's the ratio of vertical change to horizontal change between any 2 points on that line. And so if we talk about slope, we usually refer to it as an m. I'm not really sure why that is, actually. That's just the letter that we use in math to describe slope. So m is the rise over the run, so the distance up and down, divided by the distance left to right, which is the change in y divided by the change in x. So how different those coordinates are in terms of the y values and how different they are in terms of the x values. And if we want to know how different they are, we just subtract them. So if we look at, say, in this example here, let's just make up some numbers here. Let's say that this is 3, 5, and this point, that's this point here, and this point here, let's just say is maybe 6, 6, 8, something to that effect. Okay, so if we want to know the rise, that's the vertical change. So that's the difference between this y value and this y value. Well, that distance there is going to be the difference between the two y values. If we subtract the y values, 8 minus 5 is 3, so that distance there is 3. So that would be the rise. If we want to know the run, that's the distance between these two x values. So between 3 and 6, that's also a difference of 3, so that would be between these two x values a difference of 3. And so the slope then is just going to be the ratio of those two numbers. We just compare those two differences. All right. So we can do this if we have any 2 points. If we're just given the points, we've got this formula that we can throw numbers into. So we do the difference in y on top and the difference in x on the bottom. Now it doesn't matter which order you subtract the coordinates in, as long as you're consistent. So if I say do 3 minus 0 for the top, subtract the two y values. Well, I pulled the first y value from this point, so that means I also need to pull the first x value from this point as well. So I'd have to do 2 minus 1 on the bottom. So that gives 3 minus 0 on top is 3. 2 minus 1 on the bottom is 1. So we get a slope of 3 over 1. Now, just to show you that you can do it either way and you'll still end up with the same answer, let's do it the other way. So if I did this y value minus this y value, that'd be 0 minus 3. Divide that by, then I'd have to start with this one, 1 minus 2. So 0 minus 3, that's negative 3. 1 minus 2 is negative 1. Well, negative 3 divided by negative 1, that's just positive. So remember that a negative divided by a negative is positive. So this really is no different than 3 over 1. So it doesn't matter which way you do it as long as you're consistent when you do it. So if you were to say, let me give you an example of something that would be wrong. If you did 3 minus 0 divided by 1 minus 2, that would be wrong, because you pulled from one point first for the y values and then the other point first for the x values. That would give you the wrong answer. So just be consistent with yourself and you'll be fine. All right, for part B, again, we're going to do the same thing. Do one of the y values minus the other y value. We've got to be careful when we have negatives, though. So if we say do this y value minus this one, that's going to be negative 2 minus negative 6. And remember that when you subtract a negative, that's the same thing as adding a positive. So on the top, what we really have is negative 2 plus 6. Then on the bottom, we do the x values subtracted from each other. So we could do negative 2 minus 2. Negative 2 minus 2, that's going to be negative 4. And then on the top we get, see, that's going to be positive 4. Positive 4 divided by negative 4, that's negative 1. Or if you prefer to think of it as a fraction, negative 1 over 1. We can also find slope on a grid. It's actually a bit easier to find on the grid because you don't have to do the algebra, don't have to do the calculation, you can just count it. So if we want to know the slope of line A, that's going to be this line right here. And so we can find the rise just by looking at the difference between any 2 points on the line, the difference in y values. So we could look at, say, this y value and this y value. The difference between those y values, 4 and 2, is 2. So we count 1, 2 to get down to that y value. So that's down 2 would be a negative 2. So when you're counting on the graph, remember that up is positive and down is negative. And then to the right is positive, and to the left is negative. So if you count down 2, that's negative 2. Then to get over the point, we also need to go to the right 2. To the right 2 is a positive 2. So we get a slope of negative 2 over 2, which we could then reduce to negative 1. Or again, if you prefer to think of it as a fraction for slope, you could think of that as negative 1 over 1. All right, for the slope of line D, that's this one right here. So we could say take this point and this point maybe, and look at the difference between those. So if we calculate the difference in y values, well, we go up 1, 2, 3, 4. And then to the left and right, well, we don't go anything to the left and right because they're one on top of another. And so we have 0 for the change in x. So here we're dividing by 0. We can't do that, so this is an undefined slope or a vertical slope. Again, we use the word undefined because we haven't defined a way to do division by 0. It's not an operation that we can do. So it's undefined. It's not something that we have a way of doing. All right, let's talk generally about slopes. So a negative slope is a downward slope. We talk about negative slopes being falling slopes, so that falls from left to right. Positive slope rises from left to right. A zero slope is horizontal. And an undefined slope is vertical. On the right side there, when two lines intersect in a coordinate plane, the steeper line has the slope with the bigger absolute value. So if you don't remember what absolute value means, it's the kind of positive version of the number. So basically what this is saying is that bigger numbers give you steeper slopes. So whether they're positive or negative, whether they're going up or down, the bigger the number is, the steeper the slope will be. And the smaller the number is, the closer to 0 it is, the shallower the slope will be. Now there's another good way to remember which of these slopes is which in terms of negative falling and positive rising and all that stuff. It's this kind of slightly creepy picture of Mr. Slope Guy. So we've got one of his eyes is one of his eyebrows is a positive slope, and so that eye is positive to tell you that that's a positive slope. The other eye is a negative with a negatively sloped eyebrow. And then his nose is a vertical line with a little U underneath it to tell you that vertical is undefined. And then he's got a horizontal mouth with dimples on either side. Those are zeros, and so that tells you that a horizontal slope is a zero slope. So this can be helpful, especially for remembering which one is 0 and which one's undefined. That's a very easy thing to mix up. So vertical is undefined, think of his nose with a little U underneath it, and 0 is horizontal, think of his mouth with the dimples on the sides. All right, postulate 17, slopes of parallel lines. So the slope of a line kind of tells you the angle of the line, tells you how it's angled in the coordinate plane. And so if two lines are parallel to each other, that means they're angled the same way, and so the slopes must be the same. So parallel lines will have the same slope. And also, like I was talking about earlier, we have kind of caveats and special things for vertical lines. So we also say that any two vertical lines have the same slope. Any two vertical lines are parallel to each other. So any undefined slopes, those are all the same as any other undefined slope. Postulate 18. This one's about perpendicular lines. So this is how we can find slopes with perpendiculars. So there's a fancy way of saying this, which I honestly don't particularly like. So we'll talk about what this means. But it says that in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So that means product means multiply. So if we multiply the two slopes together, we get -1. Now, I prefer to think of this as being opposite reciprocals. You probably remember that term. So if you have opposite reciprocals, then they will multiply to have -1 as their product. If you don't remember what opposite reciprocals are, that's when you have a fraction, and opposite means you flip the sign. So like the opposite of 5 is -5. The opposite of -8 is 8. You flip the sign for the opposite. And then reciprocal means you take the fraction and you flip it over. So if we want to know what the opposite reciprocal of, say, 3/4 is, well, the reciprocal would be 4/3, and the opposite part would be making it negative. And if we were to multiply these together, you would see that you do get -1. So on the top, 3 times -4 is -12. And on the bottom, 4 times 3 is 12. Well, -12 divided by 12 is -1. So opposite reciprocals do multiply to give you -1. If you want to think about perpendicular lines having the product of their slopes be -1, that's fine. I prefer to just think of it as opposite reciprocals. All right, now again, we need to have an extra thing for vertical lines. So vertical lines being undefined, we can't really have that reciprocal, but we can say that horizontal lines are perpendicular to vertical lines. And I'm just going to use the perpendicular symbol there. All right, example 3. Tell whether the lines through the given points are parallel, perpendicular, or neither. So I'll use some notation here. So m being slope, I'll put a 1 underneath it, a subscript of 1. So this is the slope of line 1. So we've got 2 points that were given for line 1. So to find the slope, we can just throw them into the slope formula. That's going to mean subtracting the y values. So we could do 2 minus 3. And then put that on the top of the fraction. Subtract the x values. That's going to be -1 minus 2. And that will give us the slope. So 2 minus 3 is -1. -1 minus 2 is -3. Well, -1 over -3, that's a negative divided by a negative. That's positive, so we can say that that is positive 1/3. Now let's find the slope of line 2. So we'll take the y values and subtract them. That's 0 minus 1. Take the x values and subtract them. That's 0 minus 3. So that's -1 over -3, which again is 1/3. So these two slopes, these are exactly the same slope, so that tells us that these two lines are parallel. So again, parallel lines have exactly the same slope, and it has to be exactly the same. So I see a lot of students, when they're doing a problem like this, they'll get one of the slopes to be, say, 1/3, and one of the slopes to be -1/3, and they'll say, oh, well, 1/3, that's 1/3, so they're parallel to each other. Well, not if one of them's negative and one of them's positive. They need to be exactly the same. Exactly the same. If there's any difference between them at all, they are not parallel. So keep that in mind. They need to be exactly the same to be parallel. All right, part B. Let's look at these. So let's take the y values again and subtract them. So we'll do the slope of line 1. The y values are 5 and 4. We'll subtract those. The x values are -2 and 1. Subtract those. So we get 1 on top, -3 on bottom. So that's a -1/3. And then for the slope of line 2, the y values are 0 and 3. X values are 4 and 5. So that's negative 3 over, let's see, 4 minus 5 is negative 1. So negative 3 over negative 1, that's the same as positive 3. If you want to think of that as a fraction, you can think of it as positive 3 over 1. So now we've got negative 1/3 and positive 3 over 1. Well, these are opposite reciprocals. So 1 over 3 and 3 over 1, those are reciprocals, they're flipped. Also, one is positive and one is negative, so that means they are opposite reciprocals, so these are perpendicular to each other. And again, these were parallel for part A. All right, example 4. Find the slope of line N perpendicular to line H through point P. Then graph the line. Okay, so let's talk about what this is called. Talk about what this is saying. So we need to come up with a line, call it line N, and that line needs to be perpendicular to line H and pass through point P right here. So if we need to align perpendicular to H, what we need to do is find the slope of H and then take the opposite reciprocal. So we could go from this point to this point by going up 1, 2, 3. So the rise is 3, and the run is 1, 2, 3, 4, 5, 6. So 3 over 6. Well, that reduces to 1/2. So that is the slope of H. So if we want a slope that is perpendicular to that, we need to take the reciprocal, so that's 2 over 1, and then make it the opposite of that, so negative 2 over 1. So we need a line that has a slope of negative 2 over 1, and we need that line to go through this point. So let's just start at this point then. And then if we want a slope of negative 2 over 1, we just go down 2 into the right 1, and there's another point. Now, to get some more points on this, we've kind of run off of the graph here on the right side, so we could go to the left. So if you go down 2 into the right 1, that's really the same thing as going up 2 into the left 1. You can see we get back onto the line. So we could go up 2 into the left 1 to get another point, up 2 and to the left 1, up 2 into the left 1, and that gives us some more points that we can use to draw a line.